Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and in this week's video we're going to conclude this square peg in a round hole, or in other words mounting this Bridgeport and Bridgeport clone X-axis power feed to the benchtop mill. So let's get right back to the tying up some loose ends. What we'll do next, I will turn over to the press. We'll get set up to broach this keyway out. Okay, the keyway that's in the lead screw on the mill is a 5mm. Closest broach I got is a 3/16, which means I'm going to have a little bit of filing to do in the broach, or either a little bit of grinding to do on the keyway. We'll see which one looks like the least amount of effort. And no, my broach kit did not have a 17mm bushing. This is another piece that I made off camera. This is 17mm diameter with it keyed for this 3/16 broach. Now there's a little bit of the old keyway still there, so we're going to line this up with that. With that existing one. Alright, for this first one the broach went in there pretty deep, so well, that didn't do a good job of catching it, Lee. Alright, now we'll put one of our shims behind the broach. I suspect it won't go quite as deep this time. Okay, here's what we've got so far. I'm going to go another bushing or two, or spacer or two deeper. I know the keyway in the lead screw, there's not a whole lot left sticking up, but I'd rather have it too deep than fight with it not being deep enough. Alright, I'm going to check this depth and width, and then we'll see if it fits. If not, we'll see what we need to do as far as filing. Okay, the depth of the keyway looks good. Again, the width is a little bit more. This is 5mm, and what I had was a 3/16 broach, which means this is about 9 or 10mm. The keyway is about 9 or 10mm too big on one side. So what I'm going to do is, instead of trying to file it off or file out the broach, I'm just going to run this on the surface grinder. I've got 0 set, and I'm going to try to take about 5/1000ths off of each side and see how that does. Alright, now I'm going to flip it over. That wasn't quite straight. Try that again. That looks better. having to reach over in front of the camera to get to the controls. Not sure if you can see that, but I took about 5 thousandths off of one side. And I'm going to turn it over and attempt to do the same thing on the other side. Hoping it's still got enough surface to hold. Okay, let's see if it'll fit in now. Look at there. Fits just fine. I'm going to go back over to the mill now, set this up again, and get ready, or double check that bushing depth we need one more time. Okay, I think we're ready to do an assembly on this end. We still got our stops to put on, but I think we're ready to assemble this in. I machined the bushing off camera, which is simply some more of that stainless steel, bored out to the 17 millimeter, and I left it a full 1 inch diameter, which will fit inside here fine. So that's just the spacer. Here is our actual bushing. And I picked up some little bit longer screws that I had in my bin. Now this is sticking up above the table. I know it's a little bit unsightly, and I may cut it off one day, but it shouldn't be in the way. I've never had anything, or anything I've ever had hang off the end of the table was sitting on the vise to begin with, so it would have been above this height. All right. See if we can get that keyway turned up top. And this is the keyway that we machined half of it. And the broached gear. I got to thinking about a while ago, if I did want that handle back, what I could do. Let me get that handle and show it to you again. It's got part of the dial on it, and while the dial comes off, and that could be trimmed, as I said earlier, I want to do as little modification to the mill as possible. The only thing I've done to the mill is drilled and tapped 2 holes in it. The only thing I've done to the drive is this major part right here. I cut it in 2 and bored it out. But should I ever want this handle back on here again, I don't think it would take too much to take, let's see, my 17 millimeter test piece that I had, thread the end of it for whatever thread that is, and put that handle out here. But that's a project for another day, so stay tuned. And that doesn't need to be torqued down real tight. This is a nylock nut on there. So let's see, we're in the neutral position now. Let's turn it on. It looks like that's going to work beautiful. next to no instructions came with this. Some mounting instructions came. Of course, they're not applicable to this. But I do know this is forward and reverse. This is speed, and this is supposed to be the rapid. I have learned from just some benchtop testing, turn the speed all the way down to 0. Put it in whatever position you want, and there's your rapid. Then move a couple of tools right here. I put a red mark right here as far as to indicate how far it would travel over to the left. I know I'm going to be, or I don't know, but I suspect I'll have a little interference in there. So let's come in now. The sake of, oh yeah, we got a full 3/16 under there. All right, so I've lost about an inch of travel right here. Maybe an inch and a quarter. I could get a little more. As a matter of fact, I believe I can get every bit of that out. This rig under here, I did a video on it sometime back, or a series of videos on making this Y-axis lock. But I can modify that some and gain that inch back, I think. All right, so. So what we need to do next, this comes with a stops, so that if let's give it a little bit of speed. So if we're traveling this way and it hits that stop, that's what it does, is stop it. So let's look at mounting these the bumpers on here. All right, I don't remember exactly what this mill had in it for bumpers, if you will, to begin with. As I say, I put that feed on there right after I got it, but it did have these little wedges. Maybe you can see what I'm talking about here. There are little wedges that fit in this track. I had made these stops before. I actually did a video on that as well, on the limit switches that I had on here before. But they just happen to be the same thread as the pieces that came with this to be the bumper stops. And they fit just perfectly into that track as well. So that's something don't have to be modified. They came with these flat pieces. This one don't want to cooperate quite like the other one did. Maybe some swarf down here. Maybe it'll fit better. turn it 90 degrees. See if that, look at there. All right, I see what's going to have to be, these are going to have to be modified just a little bit. Let me take this back off and I'll show you. This surface right here, this boss, is just a little bit too thick. But we can get that off camera. For right now, let's concentrate on getting the bumper installed. So this piece is going to have to come off. And some time back, I made another little modification to this mill where I took the little twist locks off of here and made these handles, which I think are going to be too big. Yeah, what I'm going to have to do is this looks like maybe an 8mm. I'll just have to get some longer screws to mount in these. This is nothing more than a socket head cap screw pressed into this handle, and I'll just press some longer ones in there. What we need to do now is get these out of the way. And see about where this needs to be mounted. Alright, so height wise, let me get just a little block. That's a piece of 3/8 stock. Might be just a little high. Piece of 1/4 inch. Oh yeah, that should line up just fine. So what I'm going to do, and I'll save you the monotony. If you've stuck with me this long, I appreciate you sticking with me. But I'm going to mark this off, center it up, drill and tap a couple holes to mount these stop buttons. Okay, I think we're ready to wrap this video up. Okay, as I just put in the note, this content turned out to be way too long for a one-part video. So I decided to go ahead and make 2 parts out of it, but to also tie up some loose ends here. First thing, the limit switches, as we left off, are installed now for each side. And in the kit came this dust cover. So it just rides over the top of it. And as these bumpers run into that, the dust cover can move as well until the limit switch is engaged. The second loose end, you might notice down here, I set this up on 4-inch channel irons, pieces of channel iron, instead of this crusty old looking lifts I had under the legs of the table. This was about 3.5 inches. By putting the 4-inch channel iron in here, that also gave me enough lift to put the tray back under. Remember, the tray had that about a 3/4 to a 1-inch lip around the edge. I kind of wanted the tray back because occasionally coolant will splash out, flow over, and the tray just helps catch that a little bit. The next loose end, if you recall from part 1, I was having issues with I was going to have issues with these bumpers running into these custom X-axis locks that I put on. And all I did, pull that out right quick, where all these are is just some knobs I made using the using the mill and the bolt hole pattern to get this scallop around the edge. A hole in the center here, just smaller than the head of a socket head cap screw. I believe this was 8 mm, but I just took the bolts that was in there out and pressed in some longer ones. So now, even with the table locked, and remember, these bumpers and the locks travel with the table, so there'll always be, the distance between the two will always be constant. But with that locked down, there's still room. I also changed the y-axis. If you recall, the power feed was, my y-axis was sticking out here about another 3/4 of an inch. And that is taken care of now. Here's a quick picture of the y-axis I had done before, and a card up here to the playlist where I made it. But then I replaced it with this, the 2 screws. With this being up on the 4-inch channel iron now, there's much more room to reach under here. There's still a couple little sharp corners right there I have to be mindful of, but the y-axis lock is, that loose end is tied up as well. The next thing is the end cap. If you remember, the end cap for this unit stuck up about 3/4 of an inch. Well, I cut it off. Let me get around here on this side where I can run some screws in. All right, when I take this table cover off in a second or two, you can see that comes out flush now. I also determined a way, you remember I said in the part 1 that I'd probably not be able to use the handle when I put this on because the shortness of the lead screw sticking out. I have found a way to put that handle back on, and I'll show you that in just a moment. Quickly, the only modifications we did to the mill was drill and tap 2 more holes down here for the screws for the end cap, drill and tap 2 holes for the limit switch. So let's put this back together now. And as I put it back together, I'll try to show you the pieces that I had to manufacture or had to machine myself, and what I had to modify on the kit that came with it. I'm going to get the camera in a little closer. All right, there's a lot of black up in here, but hopefully you can see what's going on. The first thing, you remember the thrust bearing washer remained on here, and I milled out this sleeve, left it the 1-inch diameter of the piece of stainless steel I was using, but 17mm inside, and that's to go in just to bump against that washer from the thrust bearing. The next piece that I made, which was probably the most precision piece of all on here, was milled out to the 17mm to go over and bump against that sleeve we put in, and also fit into the diameter. This was a piece, a bushing like this came with the kit, but it did not match my lead screw. And this sleeve in here is to keep this bushing from sliding back. Now, as I pointed out earlier, the gearbox head here is keyed to this end cap. There are pins in this end cap that line this up in addition to these 2 screws. So that's pulled up on the pin now. All right, the next piece that'll go in is the key. This is the key that we had to match the 5mm into the 3/16 brooch. So I milled about 4 or 5 thousandths off of each side of this keyway, only halfway through the body. Now this is the bronze or brass gear that came with the unit. I've cleaned out the any swarf out of the gears. Got a little grease on it. That will mesh up with this worm gear down here at the bottom. All right. Now the next thing that I did, at this point is where I put the nut and washer on before to try this, and I think there might have been a little bit of footage of that in part 1, because as we can see here, the extent of that sticking out. What I had to modify on this piece was part this off. That is probably, let's see how long I had to, on mine, 1.32 inches. So almost 1.5 inches to cut off of there. But I went back and made this little adapter. And a couple of viewers on the first video suggested that, and after reading their suggestions in the comments, I decided to come back out here and just see what would be involved. And really not involved at all. I milled down a piece to the 17mm, put just a little bit of a flat right here, and its depth is the same depth as this thread. I also put a drilled and tapped for a grub screw, set screw. I don't necessarily like to put set screws on threads, but I really had no other place here to lock it, and I don't want to use Loctite on here because someday might want to get it off. But with that thread on here, and I'll just use that flat just to tighten it down. Then I'll tighten this grub screw. Try not to destroy the threads, but just to grip into them. Now I also went back to the press and milled out a keyway here. And remember, that was the 3/16. And the handle has actually got the 5mm. So there's just about 10 thousandths slack in the handle. But I'll own up to my mistake as well. I milled that 3/16 out just a little bit too deep, so I'm just going to put a little piece of sheet metal in there to use as a bushing, just to raise that key up. I also, instead of the washer that came on here, I just went ahead and milled out one, or made one on the lathe, kind of a fender washer, to be sure it bumps out here on the handle and is a closer fit to the thread than the original was. And then the locking nut. I've read and heard that you should not use these lock nuts more than one time. If you take it off, you should throw it away. I'm not usually that particular, but the one that was on here, the original one, I had taken on and off probably a dozen times or more, measuring and testing and whatever, so I am using a new one in here. You want that snug, but I don't want it binding by any means. So And there's that little bit of play between the 3/16 and the 5mm keyway. All right, let's turn it on. Get a few pieces out of the way up here. Now, something I'd like for you to note about this kit, I hope you can hear it as well. When I go back to the off position, the gear motor does still coast, but if you'll notice, the lead screw brake comes on it. All right, I'm going to get the camera repositioned one more time, and we're going to actually make a test cut using this X-axis power feed. All right, first thing I want to show you is what this looks like from the end. I did take the dial off of my handle. Frankly, I've never used the dial from the beginning. Within days of getting this mill, I put a DRO on it. It was a little small eye gauging DRO, but I put that on there. Now I've got the just a standard type DRO on now. But this is the brass looking at it. And remember, if we hadn't cut this off, the handle would have been on out here another 1.5 inches. So I didn't plan for this to match up so well, but it sure does match good, and it worked out for this. Next thing I want you to see is the clearance on this side over here. I've got some information here. With the old setup, I had exactly 14 inches of travel on the table. With this setup, after modifying this, I've got 3/8 of an inch more travel than I did before. Pretty much the end of the table comes within about a 5/8 inch of the cross slide down here. So I gained about 3/8 of an inch. With the old homemade power feed I had on here, it took 54 seconds to go from end to end. Now it takes 37 seconds. Not quite twice as fast, about 40% faster. The table height, even after going with the 4-inch, I'm 1 inch higher now than I was before. And again, I don't mind that at all. I don't like to bend over doing work, so if I can keep it up a little higher, it's fine with me. All right, we're going to put it in feeding to the left now. Note the space over here, how this goes up under with the channel now, and also the limit switch. Now we can go, I'll go to full speed and go to the other end. This is real time you're watching right here. And hopefully you'll be able to see under the vise when they move you over just a little bit. When this bumper runs into the limit switch on this side, I'm going to slow it down before it actually runs into it though. All right, I'm going to load a piece of material in the vise now, and we're going to make a cut. All right, the piece I'm going to do a test cut on is just some mystery metal over here. This is steel. It's a little over a 1/2 inch thick. Mount that in the vise. So I need a thinner parallel though. All right, and I have a 1/2 inch roughing end mill in now. All right, I'm going to come up and touch off On the z-axis, 0 that. All right, so what should we take for depth? That was 50. There's 100, 150. Let's see if this little tabletop mill can cut 200 thousandths deep, full width of the cutter, and the power feed not stall out. I'm going to try to zoom in and give you some various shots of the end mill cutting, also of the power feed as it's working. And you may have noticed in that little run a while ago, this handle over here, this can be engaged or disengaged. So I've got it disengaged now. It should just swing freely over here. All right, I'm running at 1120 RPMs. Be sure I got coolant going on it. The dial down here on the power feed goes from 0 to 9. I've got it set at about 2.5 right now. A question was asked, one of the commenters on Facebook was, how slow will it go? Watch the handle down here. That is on about 0.5 on the dial. Again, I'll test this at about, I think probably 2.5 is plenty enough for this big of a cut. Now I hope you noticed that when it cleared the piece of the end work, or the end of the workpiece, it didn't surge. That was one of the issues I was having with the homemade one. I was having to crank up the power to it to get a cut, and I could nowhere near do 200 thousandths deep in a piece of material like this, a full width, with that power feed. I probably don't have another 200 thousandths to go on this workpiece, but it would surge with the old one. Once it come off the end of the work, it would surge out and pretty much wake you up, in other words. All right, let's go down another, just 100 thousandths now. Don't want to run into my vice jaws. And we can come back in the other direction. And I can probably go on up with the speed a little bit. That's about 3 on the dial now. All right, I think we're going to conclude this video now. Frankly, I'm thrilled with the way this turned out. Again, I had to do just a little bit of modification to the mill, drilling, tapping 4 holes setting it up a little higher here. A little bit of modification to the parts that came with this drive. In other words, that brass or bronze gear there had to shorten it. Hindsight, I could have got away with leaving it full length and just extending the shaft on out like I extended it for the handle. But this turned out fine. Again, overall, I'm very pleased with it. I hope you've enjoyed the two parts. If you've got an idea or thoughts of doing this, the only thing I would warn you about to begin with is just be sure that your lead screw shaft is not too big for that dimension I gave you in the first part for the outside diameter of the bushing that came with it. In other words, the gear ring in here. Because you can always make another bushing just like I did to go larger or smaller as necessary. Take care. I'll see you on the next video.